Hey guys, it's Ben, and today I'm going to be walking through the Photobomb Hack the Box challenge. This was an easy rated Linux box, which to be honest I thought the user flag or the initial access stage was a little bit trickier than easy. There was no vulnerability or publicly accessible exploit, so you had to create your own exploit to gain a shell, which is quite fun, but it makes it a little bit trickier. After that, the privilege escalation stage was fairly straightforward. I've got the box up and running, so let's get on with it. I'll copy the IP address, and we can start off with a ping check to make sure it's up and running. Paste the IP in there. We can see we're getting ICMP packets back. This box is up. It is running. I always like to run an mmap scan, so let's paste the IP in there, and I'll quickly run through the switches I'm using. The ports I want to scan them all. I want to get full coverage. I don't want to miss anything. I want to identify all routes that we could possibly attack this box. So I'm going to do TACP. That will scan all the TCP ports. I also want to identify the software which is running these ports, the services which are running, and potentially the versions of those services. So I'm going to do TAC-SV for service version enumeration. TAC-SC to use the default NSE scripts, that is the Nmap scripting engine scripts. That will give us a bit more information on the ports which are open. It will give us some hopefully useful information which we can use. TAC-PN to not send a ping check. We know it's up and running. This will just slow it down a little bit. TAC-T4 for a speedy output. TAC-N to not do a reverse DNS check. And I think that's it. I'm going to output this to a file so I can reference it at a later date. The file will be full thorough.log. I have already ran this command, so I'm not going to run it again. We can see it's there, and I will cat this open, and we can see the command I ran was up there, and we can also see there are two ports open. The first port is SSH on port 22, the default port. We can see that the software running this is OpenSSH, and there is a version there. We can also identify the operating system which is running this, and that's Ubuntu. We've got some idea of the SSH keys here, the public keys, but we don't need to really look at this. If you've done a lot of Hack the Box challenges, you'll know for initial access, attacking SSH, brute forcing it, is never really the way to go. It's typically another port which is open, and in this case there is only one other port, being HTTP or port 80, so we'll know this is our route for initial access. We can see from the NSE scripts we've got this HTTP title, which is the title of the web page when the request was made to this IP address. We can see the title does say did not follow redirect to http photobomb.hackthebox. So this reveals the host name of the machine. So we can add this to our etc hosts file. Etc host file, and I'll just head it here. Etc hosts is basically your local DNS cache. We can go sudo vi etc hosts, and we can see somewhere down here, I'm not sure, let me just do this, Photobomb. We can see down here, I've already added it to my host file, so we can see the IP of the box 10.10.11.182, and then the host name there, photobomb.hackthebox HTTP. So this means we no longer need to reference the IP, we can purely reference the host name, and we can ping photobomb.hackthebox, and we can see we're getting ICMP packets back from the IP address. So we've got all the foundation set up. We can actually visit this web page now and see what we find out. So we'll go to Photobomb, photobomb.hackthebox, and we can see we redirected this page here. Welcome to your new Photobomb franchise. You will soon be making amazing income selling premium photographic GIFs. We can see there's a button there, and in the bottom left hand corner we can see this redirects to /printer. So we can click on this, and we can see we're redirected to ask for some credentials. We don't know the credentials, but we can try some default ones: admin, printer perhaps, admin password, username, password, photobomb, it's always a good idea when you get some login page to just try the default credentials, see what we can discover that way, and then perhaps later, if need be, we could throw Hydra at this and brute force the HTTP authentication. In this case, I'm going to stop looking at that, as we don't need to. There's other stuff we can dig into. We can do some more enumeration and figure out some more stuff. We can see, look, the web server or the reverse proxy is Nginx. That's probably not that's the web server we can see. There may be a back-end web server which is doing something, but it's protected by an Nginx reverse proxy. We can look at the source code and see if we can reveal anything else here. We can see, look, there's that redirect to printer button. We can also see there's this JavaScript script which is included, and an external JavaScript script. We can click this and view this, and we can see function in it, and then there's a comment: Jameson, pre-populate creds for tech support, as they keep forgetting them and emailing me. We can see there looks to be some credentials which are revealed for HTTP authentication. We've got a username and a password there, Photobomb. So what I'm going to do is I'm going to copy these, and I'm just going to go over to my thing here and say creds. Creds, we'll add it there, and we'll leave this. I'm just going to cat the creds out so we can see. So we've got these credentials. We can go back and try this again. Try this page. We can try printer as it was, and we'll try these creds. So photo, and then bomb. We'll paste this in here, and we can see we can now sign in with logged in to the page. Though they've obviously used very poor practice of storing plain text creds on the front end web page where anyone can access them. That means we can steal those credentials and log in. Before we dig around with that, I am going to do some fuzzing to see if there are any other directories or pages which reveal any other information. And to do that, I'm going to use the fuff tool, or fuff. The word list I'm going to start off with is a directories word list. On my Kali machine, this is stored in user share, word lists, sec lists, discovery, web content, raft, medium, directories. So this is a good word list we can start off with. TACU is for the actual endpoint we're trying to fuzz, and in this case this will be HTTP, photobomb.hackthebox, and then you indicate where you're sort of placing the word from the word list with fuzz in all capitals there. So it will go through one by one through this word list and place the word there, and then we want to filter on something because we don't want to return all the results. We want to return only the juicy, interesting results. So we can go to a random page here. Let's just say I'll duplicate this, and we'll go to like random page, and we can see we get this sort of 404 message. It looks like it doesn't actually say 404, but it says Sinatra doesn't know this ditty, and then it gives us some try this instead. So we do get some sort of back-end web server revealed to us, and that's the Sinatra web framework. That is interesting. We may need that later if we're doing some exploitation on that. We can look and inspect and see when we actually send this request, we do get a 404 not found error. So therefore we can filter on the 404 not found error, filter code 404. We'll start this, and it's I'm going to stop this because I need to zoom it out a little bit. It's not doing it clearly. There we go. We should be able to get a better output now. We can see that printer directory was found. Over time it will find more and more. We can also see printers was found, so we can go to printers, check that out. Printers. And it looks like, for some reason, it gets a 404. Maybe it's a 401 which redirects to a 404. It's a bit strange. There's also printers, printer friendly. So let's try this. We can see that also gives us a 404. So this was something strange I discovered. I don't really know why this gave us a 401. What I did notice is if instead you went to like this, Photobomb. So I'm not logged on, so if you go here, it prompts for it again. If I go to printer friendly, it will also prompt that. So once we've got like that authorization, that like my session cookie, I guess you could call it, my authorization cookie to say I'm allowed to log in, and it saves my session. After that, it gives us a 404, but when I don't have that, it prompts us for that login box. It doesn't matter, we've logged in anyway. This looks like a photo downloading page, so we can see download photo to print, and there's these different options for dimensions, and then a file type button here. We can click on these different files here, and just for example, we'll download this one as a PNG, and then we can open it up, and it does just download the image. So we've got all different options. If we do a larger photo, does this actually adjust the size? It takes a little bit longer, so maybe it does. We can look on the size, it does change, and if you look, that one's 104 kilobytes and that's 8.3, so it is likely the size has changed between the two. We can see that. So this web application allows us to change the dimensions of a photo, of a set predefined photos here. It also allows us to change the file type to download. That's pretty interesting. What we can do is open up Burp Suite and interact. We can look at the traffic which is being sent. Intercept it was the word I was looking for, and then possibly play around and tweak it to see if we can discover anything interesting. So I've got Burp Suite open. I've got Intercept on. I've got my Foxy proxy here, so I'm going to choose to redirect all my traffic to my local host on port 8080, which is what I've configured on Burp Suite. So now when I make a request, it will proxy it through Burp Suite, and then in Burp Suite I can play around with it and have a play, basically. So in this case, I'm just going to pick this image. I don't mind the size. I'm going to just choose a smaller dimension. We can say change this to PNG. We'll download this, and we can see we get the request sent to here. It's a post request to the printer endpoint. We've got the post parameters passed there. There's a photo, file type, and dimensions. The authorization is just my credentials. That's like the authorization HTTP header, which is how we're sort of accessing this in the first place. If we didn't have this, this would be out of bounds, basically. What I'm going to do is I'm going to send this to the repeater, and this will allow me to send requests, edit them, and play with them. And in this case, when we send this request, we get the PNG file as just binary data returned to us. If this was on a browser, we would download this image. In Burp Suite, we just get the binary data. We can see the content length there, so we could try play around. Perhaps there may be some command injection. We could do an ID. We could fuzz and see if this content length changed for a particular thing. We get this error: the source photo does not exist. So at this point, I thought maybe there's some sort of local file inclusion, and I could go like this and go etc password, and we can see invalid photo. So it does try to read this file, but I think it can tell it's not a PNG. I don't know how it's checking. Maybe it's looking at the magic bytes, maybe it's looking at the file extension. I'm not sure. We could try etc password.png, see what this does. It says invalid photo as well. So that's a bit interesting. I'm going to, if I just paste this back to what it was originally, we can see we make this request. There we go. The next thing I wanted to try around, what if I did a custom dimension? So we can see we've got the dimensions there which are preset. What if I do a random dimension? So let's just try this dimension here, which isn't in our list. If I send this, what does it do? It thinks for a while. A lot of these responses take a little while to run. In this case, it looks like it has returned. Maybe we are able to use custom dimensions. I could sort of scale this up massively and just see if the content length changes by a large amount. So this is 650, 405. At this point in the challenge, I was just playing around. earlier we did notice there was the Sinatra, that was sort of the back-end web server, which we saw ran on Ruby. You may just want to play around, and this is what I did do, until you find something potentially interesting. In this case, we can see the content length has changed. It looks like we can supply custom dimensions. What about if we supply a custom file type? So let's just say exe, something random. Obviously, there won't be an exe image. It says invalid file type. So there is some check for the file type. Is it if it just contains JPEG? So if it did something like JPEG exe, I want to know how this check works. We can see we get some really weird response here. So I don't know what this is doing, but it looks very strange. We can see some PKIK, so I believe that PK is some sort of magic byte. I don't know. We've got a really weird response here, so I knew something was going on. Something really strange was going on. We can also see what looks like to be some sort of, I've seen this in the PNG header before. I don't know what this is, but it's a bit worrying. So at this point, I thought maybe there's some command injection. Maybe I can go something like ID, and we can get command injection. At this point, when I did this, I noticed I didn't get that error code, so that error. So we see we get that failed to generate a copy of this. Before, when I did this, and I'm just going to lower the dimensions just so the responses are a bit quicker. Just do 10 by 10, something really small. So before, when I did a random file type, we get this this message here, right? Invalid file type. When I include JPEG, let's say JPEG and then semicolon ID, we get failed to generate a copy of Nathaniel Royal, this thing. So it's not giving us the invalid file type, it's recognizing this as a legit file type. And then perhaps, we don't know, maybe it's executing this ID command. This could be a, let's say, a blind command injection, and we cannot see the response no matter what we do. We could try, let's just like a ping check to ping our own host. So my IP address is hidden by my face. I'm going to move it across. My ton0 IP address for my VPN, my OpenVPN VPN, is 10.10.16.6. So what didn't mean to do that, sorry. So what I could do here is try ping 10.10.16.6, and let's say we'll get TCP dump on ICMP going. So we're listening for pings, and then I'm going to ping my IP address. What we will need to do is URL encode this, so I can do Control U, and that will just add the plus there to URL encode it. We can send this, and we don't get a response. So it's like something's thinking, or in this case, it could be running pings. We'll go back here. We can see we are receiving ping packets. This is great. We have achieved command injection. In fact, we've achieved a blind command injection. That means we do not see the response of the commands we are running. So we can run a command, it will get sent to the back end, it will execute it. In this case, in a bash shell, it's just executing the Linux command ping and the IP, and it's running it, but we don't get a response. So at this point, it should be fairly simple to get a reverse shell. So what I'm going to do is try a few things. We'll go back out of here. We'll go to the exploits directory, as we'll likely need to be here. And I always like to go to revshells.com. It's a great website. I've still got my Burp Suite proxy on, so I'm going to disable this. We've got my IP address filled out in there, 10.10.16.6. We've got a load of reverse shells here we can try. We can just copy one of these, for example, and replace that here, where the command is being run. And once again, I'll do Control U to URL encode it. We'll send this, and we'll go back to, I didn't actually get a listener going, so I'm going to get a reverse shell listener, netcat listener. Zoom in a bit. Try this again. We'll send this again, and we'll go back. We do not get a response, so that didn't seem to work. Another one I like to try is this MK FIFO. This one is quite reliable with netcat. So I'll paste that in there. once again, URL encode it, Control U, and then we'll send this request. One thing to notice, there is no response coming back, which is usually a good thing when you send a reverse shell, because it's likely the process hasn't finished and it's not allowing the HTTP request to be sent back because this netcat shell has been caught. In this case, we have got the reverse shell, but let's say we want to run a command like id, we can run a command like id, we can run ls, so we have got a shell. What I can do is go export term xterm, and this will allow me to clear my screen, just exporting that terminal environment variable. We can also, at the moment, it's not a fully functional PTY shell, so I can use Python to upgrade this to a PTY shell. We can see what version of Python is installed. There is not that Python version. Is there Python 3? Which Python 3? And there is Python 3 installed. So we can go Python 3 taxi, and it looks like that. Let's see if we've still got this shell. Import pty.spawn bin bash, and this will just give us a pty shell that ran. Nice. We can have a look around. We can see there's the user.txt flag there. Go ls-tac-la, we can see it is owned by root, has the group permissions of wizard, and the wizard group bit has read permissions over it. We are wizard, we can read this file, so that's all good. We can read the user flag at this point, you can grab it. I'm not going to cat it open and spoil the flag, but we can read it. When I've gotten a shell, and I want to privilege escalate, there are a few checks I always do when I've gotten this initial access before getting limpies in and running that, which gives us a lot of information, can be quite overwhelming. There's a few simple, easy win checks I do. One of those is sudo tac-l. So in Linux, you can be configured as a particular user to run sudo, and in this case, we can run as sudo without a password with this setenv bit, which is setenv, so we can set the environment variables, and we can run this script here, opt-cleanup.sh. So let's just open this. Let's cat opt-cleanup.sh, and we can see it's a bash script, right? It starts off by changing directory to this home directory. It then does an if statement, which apparently cleans up the log files. Then it uses bin cat to cat this file into an old log file, and then it uses this truncate binary to do something to the log file as well. After these commands are run, there is the find binary used. An important, very important thing to notice, the full file path of find isn't defined here. So it's just this find. So this will allow us to create our own find binary, our own find command basically, and in fact that will be a malicious reverse shell. As we can run this as root, we're able to execute this find binary, which is our own rogue find binary, and get a reverse shell as root. That is what we're going to do. All the other binaries, for example, cat and truncate, the full file paths are defined, so we can't do anything with those. In this case, find is not. One thing I just want to explain, when I use the command find, we see it does run something, and it ends up displaying all of this. It works when I run a command, let's say cat, or, okay, that's going to kill my shell, isn't it? Sorry. Let me just, I've accidentally killed my shell. I'll get this back real quickly, if I can. There we go. Export term equals xterm. Python 3 taxi import pty.spawn bin bash. There we go. Clearing, and we're going back to where we were. When I use when I type in a command for a binary, for example, find or whatever, how Linux finds this binary is the path environment variable. So there are a set number of directories where it will go to check for this binary. So it will first go to user local sbin and say, is the find binary in here? If not, it will go to the next one along and check, is the find binary in here? If it's not, it will go to the next one and check it one by one through all of these directories set in the path environment variable until it finds the correct one. When it finds the correct one, it will execute that. That's quite useful for what we're doing next. Like I said, sudo tac l with identified opt cleanup, so we can just cat this open again. And what I'm going to do is I'm going to create another reverse shell over here. I'm actually going to create this in the. I'm going to make a directory called pe, privilege escalation, cd to pe, and it's just going to be this bin bash reverse shell, but I'm going to change the port. I've already got this reverse shell here running on port 444 over here, so I'm going to go vi, I'm going to call this find, and I'm going to zoom in a bit, paste this in here. I'm going to change this to port 4443. So we'll leave this. I'm going to get another shell open. We can see if I cat find, we've got the reverse shell listening on port 4. No, sorry. We've got the reverse shell payload here for port 4443. I'm going to get a listener down here for port 443. And on this side, I'm going to get a HTTP server on running on port 80. This will allow me to download this file. So in this case, I'm going to use wget to download a file, and I'm going to zoom in a bit, and I'm also going to clear this out. There we go. I'm going to go wget http. I'm going to reference my VPN IP, which is 10.10.16.6, and I'm going to download find. Nice. So we've got find there. At the moment, it is not executable. So I'm going to chmod plus x on find, and now we can see it's executable. Like I said earlier, there's this opt cleanup file. We've got this set env permission set, which basically means we can run this as root. And for example, if I ran this as root now, sudo opt cleanup.sh, it just runs it. We can see we don't get a reverse shell. We want it to execute find, but that's because root has its own path environment variable of the places it will go and check for the find binary. I want it to check in the temp directory, but obviously it isn't configured to check there first. What I'm going to do is use this set env, and we can just do some googling to show how it's used. Set env Linux, and this will basically allow us to, if I want to find an example of where it's used, it will allow us to set the environment variables inside the command. So we will be able to go sudo, and then in the command we can set the environment variables. I'm going to set it to path equals to, and I want at the top of the path variable to be temp, because I want that location, the temp directory, the TMP directory, to be checked first, as when it checks it, it will find the find binary, which has this reverse shell to port 443. So I want that to be checked first, and then I can put my old environment variable there, and then I'm going to run opt cleanup.sh. When I press enter on this, we can see we've got a reverse shell on this end as the root user. I can go, for example, cd to root directory, ls-tac-la, id, who am I? I've got the root permissions. I'm running as root, full access as root. We can see I've got read access over the root.txt file. So I've got the root flag, and I've solved this challenge. This, like I said, that the privilege escalation bit was a little bit more straightforward than the user flag, but we have solved the challenge. So I hope you've enjoyed, and I will see you on the next one. Cheers.